Good afternoon, students. In the last class, we were discussing about the pressure, right? So, what is pressure means? It is defined as the force which is acting normally per unit area of cross section or per unit area, right? So, per unit area, if the force is acting perpendicular, then that we call as the pressure, right? So, in the last class, we discussed about the pressure at any point inside the fluid, that is either it may be in liquids or it may be in gases, right? So, for that, we consider one container, right? So that container having a liquid of density rho, liquid having its density rho. So where density rho is equals to mass divided by volume, right? So its SI unit is kg per meter cube, right? So first we consider one vessel or container. So in this container, it consists of a liquid which having the density rho, right? So now consider one area of cross section A at a depth h from the surface of the liquid, right? So ಈ container ಅಲ್ಲಿ liquid ಇದೆ, so ಈ liquid ಒಳಗಡೆ we consider one area of cross section, so that area is how much? That is A. So ಎಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ? It is at a depth h from the surface of the liquid, right? So now construct one cylindrical column or volume element. So ಅದನ್ನ ನಾವು cylindrical column ಅಂತ ನಾವು ಕರೀಬಹುದು ಅಥವಾ ಅದನ್ನ volume element ಅಂತ ನಾವು ಕರೀಬಹುದು, right? So we consider one cylindrical column from the surface of the liquid. So in liquid surface in the we consider one cylindrical column, right? So column cylindrical column length ಎಷ್ಟಿದೆ? h ಇದೆ, ಅದರದ್ದು area of cross section ಇದೆ a ಇದೆ, right? So now the liquid which is present in the container acts the force, that is exerts the force onto this cylindrical column. So this we considered as an imaginary cylindrical column or volume element. So one cylindrical object ಅಂತ considered ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So that is the imaginary object that present in the liquid, right? So now the liquid is exerts the force on the cylindrical column. So ಈ cylindrical column ಮೇಲೆ force act ಆಗ್ತದೆ, right? So it exerts the force onto the cylindrical column, right? So now if you observe the force from the left side and force from the right side of the liquid to the cylindrical column, so because the fluid is at rest, so initially the liquid is not at rest. So here we are studying about the liquids at rest. So liquids rest allidaga, so liquid content, the volume is also in equilibrium. So hence the force which is acting from the left side is equals to the force which is acting right side. So left side ಅಲ್ಲಿ ಎಷ್ಟು force act ಆಗ್ತಾ ಇರುತ್ತೋ right side ಅಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ force act ಆಗ್ತಾ ಇರುತ್ತೆ. So hence force is a vector, opposite direction ಇರುತ್ತೆ. So net force onto the cylindrical element on the vertical column ಏನಾಗುತ್ತೆ ನಿಮಗೆ 0 ಆಗುತ್ತೆ, right? So the only the force which is acting perpendicular to this area of cross section. So ಈ area ಮೇಲೆ force act ಆಗ್ತಾ ಇದೆ, right? So the force which is acting perpendicular to this area, so that means the pressure is acting at the point A or at the surface A, right? So now the liquid which is contained in this cylindrical column, so that weight is acting vertically downwards, right? So from this we can write, so weight contained in the cylindrical column is equals to force exerted by the liquid on the area A, right? ಸೊ ಈ ಸಿಲಿಂಡ್ರಿಕಲ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಲಿಕ್ವಿಡ್ ಇದೆ. ಸೊ ಲಿಕ್ವಿಡ್ weight ಯಾವ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ, it is always acts vertically downward because it has the acceleration due to gravity that is always towards the center of the earth. So that's why it acts vertically downwards, and the force which is acting vertically upward at the surface A, right? So from the vectors, so weight is balanced by the force, right? So weight contained in the cylindrical column, that is mass into acceleration due to gravity, that is equals to the force which is exerted by the liquid, that is F, right? So from the mass and density relation, so mass we can replace by density into volume into G, that is equals to F, right? So again the volume of the cylindrical column that can be written H into A. So length into area of cross section, or area we call that one as volume, right? So that is into G, that is equals to F. So shift the A to the RHS, so then rho G H, that is equals to F divided by A. So from the definition of the pressure, so force acting normally per unit area, right? So here the force which is acting perpendicular to the area, so that we call as the pressure, right? So from that P is equals to rho G H. So this is the pressure at any point inside the liquid, right? So next, ಇದನ್ನ ನಾವು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ನೌ we are going to discuss about the gauge pressure, right? So this is the normal pressure. So here we are going to discuss about the gauge pressure, right? So what is gauge pressure? So gauge pressure is the pressure which is relative to the atmospheric pressure, right? So gauge pressure andre enu andre, it is also the pressure which is relative to that of the atmospheric pressure, right? So it is a pressure relative to the atmospheric pressure, or in other words we can say that it is the difference in pressure between the 2 points in a fluid when it is in vertical. So vertical alli two different points alli pressure difference ಏನು ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, gauge pressure ಅಂತ ಕರೀತೀವಿ. So now we are going to derive the relation for the gauge pressure. So gauge pressure with respect to the atmospheric pressure, right? So by using the same container consists of the fluid or consists of the liquid which having the density rho, right? So now we consider the cylindrical element or volume element which is at a depth h. So the total cylindrical element is at a depth h from the surface of the liquid, right? So ಈಗ normal pressure na define ಮಾಡ್ಕೊಂಡಾಗ ಏನಂತಂದ್ರೆ one surface of the cylinder is touches with the surface of the liquid, right? So now to find the gauge pressure we are sending depth with the surface of the liquid. So in liquid surface ಇಂದ ಸ್ವಲ್ಪ depth ಅಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, ಈ cylindrical element ನ place ಮಾಡ್ತಾ ಇದೀವಿ, right? So same diagram, little bit change. Right? So again consider one container. So that container consists of a liquid. So is the liquid is there. So that liquid having the density rho. So density na define ಮಾಡ್ಕೊಳ್ಳೋದು rho symbol ಅಲ್ಲಿ. So density is defined as mass per unit volume, right? So consider a vessel. So in this vessel it consists of a liquid which having the density rho, right? So now consider one cylindrical volume element of length delta h. That means we consider one small volume element or cylindrical column. It is at a depth h from the surface of the liquid, right? So previous diagram alli enitu andre ee surface of the liquid column touches with the surface of the liquid. So one surface touches with the surface of the liquid itu. So now we are keeping the liquid column at a depth h from the surface of the liquid. So surface of the liquid inda ಸ್ವಲ್ಪ depth alli ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಒಂದು cylindrical column or the other word is the volume element, right? So this one is the cylindrical column or volume element, right? So its length is how much? So we taken the length of the cylindrical element is very small, so that we taken delta h, right? So delta h is the length of the cylindrical column, right? So now this cylindrical column having the two surfaces, right? So that one is the top surface, we call that one as 1, and the bottom surface we call that one as 2, right? So in cylindrical column ge namge ಎರಡು surface ಸಿಕ್ಕಿದೆ, one the top surface and the another one is the bottom surface, right? So same as the liquid exerts the force onto this cylindrical column. So in cylindrical column ಮೇಲೆ ಏನು ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ನಮಗೆ force act ಆಗ್ತಾ ಇದೆ. So in all directions force is acting, right? So along horizontal, the force which is acting from the left side is equals to the force which is acting right side. So liquid exerts the force onto the cylindrical column. So left side ಮೇಲೆ ಎಷ್ಟು force act ಆಗ್ತದೆ, so right side column ಮೇಲೆ ಕೂಡ ಅಷ್ಟೇ force act ಆಗ್ತದೆ. So hence the opposite forces ಏನಾಗುತ್ತೆ ನಮಗೆ cancel ಆಗುತ್ತೆ, right? So magnitude same ಇದೆ, direction opposite ಇದೆ. For example 5 Newton left side ಅಲ್ಲಿ act ಆಗ್ತಿದೆ, 5 Newton right side ಅಲ್ಲಿ act ಆಗ್ತಿದೆ. So opposite direction ಇರೋದ್ರಿಂದ 5 minus 5 ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ, right? So now the variable forces which is acting onto the cylindrical column, right? So some force which is acting at the surface 1 we call that one as F1, and the force which is acting at the surface 2 we call that one as F2, right? So here force ಆಯ್ತು, one is the force F1 which is acting at the top surface of the cylindrical column, and the another force which is acting at the bottom surface of the cylindrical column, right? The another one force which is acting means the liquid which is contained in the cylindrical column is acting vertically downwards, that means weight of the cylindrical column, right? So cylinder ಇದೆ ಅಂದ್ರೆ ಇದು mass ಇರುತ್ತೆ liquid ಗೆ, so ಆ mass ಇರೋದ್ರಿಂದ ಈ cylindrical column ಅಲ್ಲಿ ಏನಿರುತ್ತೆ weight ಇರುತ್ತೆ, so ಆ weight ಯಾವ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ vertically downwards, right? So weight is acting vertically downwards, right? So we are studying the fluids at rest. So this container consists of the fluid or liquid which is at rest, right? So that is liquid at rest, right? So liquid at rest alli the volume which contained in the liquid or container is also in equilibrium. So equilibrium alli sum of the forces is 0. So sum of the forces acting on the cylindrical column is 0, right? So iduna ನಾವು laws of motion ಅಲ್ಲಿ ಕೂಡ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ, equilibrium of forces. So here the three forces are acting onto the cylindrical column. So these three forces is equals to 0 because the liquid is at rest, right? So liquid rest ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ the sum of the forces which is acting onto the cylindrical column is also in the equilibrium. That means sum of the three forces is equals to 0, right? So first various force acting on the cylindrical column. So ಇದನ್ನ ಒಂದು imaginary ಅಂತ ಕನ್ಸಿಡರ್, ಅಂದ್ರೆ ಅಲ್ಲಿ ಒಂದು ಸಿಲಿಂಡರ್ ಶೇಪ್ ಆಬ್ಜೆಕ್ಟ್ ಇದೆ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು we are going to find the gauge pressure, right? So actual objective place ಮಾಡಿದ್ರು ಕೂಡ ನಮಗೆ ಅದೇ ಬರುತ್ತೆ, but here we are considering that cylindrical column is imaginary. So ಅಲ್ಲೊಂದು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ ಅಂತ imagine ಮಾಡ್ಕೊಂಡು we are going to derive the relation, right? So various forces acting onto this cylindrical column. So in that the first one is force F1, right? So force F1 acting on the top of the column, right? So first force act ಆಗ್ತದೆ, ಎಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತದೆ? ಟಾಪ್ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಸಿಲಿಂಡ್ರಿಕಲ್ ಕಾಲಮ್ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ. So force which is acting perpendicularly, and here is the area. So cylinder ಅಲ್ಲಿ cross sectional area ಎರಡು ಕಡೆ ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So force which is acting perpendicular to cross sectional area, so from the definition of the pressure we can write P1 that is equals to F1 by A. So here we need force, so that's why F1 is equals to P1 into A. So P1 is the pressure which is acting at the top surface of the cylindrical column, right? So the next second one is top of the column vertically downward. So why? Because force is a vector, we need to mention the direction, right? So the second one is force F2 acting at the bottom of the column vertically upward, right? So F2 is the force which is acting vertically upward. So upward directionally force act ಆಗ್ತದೆ. So that force is again perpendicular to that of the cross sectional area of the cylindrical column. So cylindrical column the area ಏನಿದೆ ಅದಕ್ಕೆ again perpendicular ಆಗಿ force act ಆಗ್ತಾ ಇದೆ. So again from the pressure relation we can write F2 is equals to P2 into A. So cylinder ಅಲ್ಲಿ area of cross section same ಇರುತ್ತೆ. So ಎರಡು ಕಡೆಗೂ ನಾವು A ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ. ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ A1 and A2 ಬಿಕಾಸ್ ಸೊ ಸಿಮೆಟ್ರಿ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ A ಇತ್ತು ಅಂದ್ರೆ ಮೇಲ್ಗಡೆ ಕೂಡ ನಮಗೆ A ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಆನ್ ದ ಥರ್ಡ್ ಒನ್ ಇಸ್ weight of the liquid present in the cylindrical column acting vertically downward, right? So again ಹೇಳಿದಂಗೆ ಈ cylindrical column ಅಲ್ಲಿ liquid ಇರುತ್ತೆ. So because this container fully consists of liquid, so ಇಲ್ಲಿ ನಾನು empty space ಬರ್ದಿದ್ದೀನಿ, dotted lines ಬರ್ಕೊಂಡ್ರು ಬರಿಬೋದಾಗಿತ್ತು ಬಟ್ ಕ್ಲಮ್ಸಿ ಆಗುತ್ತೆ ಅಂತ ಅದನ್ನ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ. So ಇದರಲ್ಲಿ liquid ಇರುತ್ತೆ. So entire vessel consists of liquid, so hence this imaginary cylindrical column also consists of liquid. So that liquid having the weight, so that weight is acting vertically downward. So the opposite direction ಅಲ್ಲಿ act ಆಗ್ತದೆ vertically downward. So hence weight W is equals to mass of the liquid into acceleration due to gravity, right? So these are the three forces which is acting onto the cylindrical column. So in cylindrical column ಮೇಲೆ ಈ three forces act ಆಗ್ತವೆ, right? So next, so you continue with that. Since the fluid or liquid, so liquid considered ಮಾಡಿರೋದ್ರಿಂದ is at rest, right? So the fluid is at rest, so hence the forces are in equilibrium. So equilibrium alidala net forces acting on the cylindrical column is 0, right? So F1 which is acting vertically downward plus weight which is acting again vertically downward and the force F2 which is acting vertically upward, right? So downward ge ಎರಡನ್ನು ಪ್ಲಸ್ ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ opposite direction ಅಲ್ಲಿ F2 ಇದೆ, so hence we taken minus F2, right? So that is equals to 0. So we know the values of F1 and F2 in terms of pressure. So that F1 is P1A plus mg minus P2A, that is equals to 0, right? So shifting P2A to the RHS and P1A to the RHS, so P2A becomes plus P2. So P1 plus P1 RHS shift ಆದರೆ minus P1. So ಎರಡರಲ್ಲೂ A common ಇರೋದ್ರಿಂದ we can take A as common, right? So in the LHS we having the value that is mg keeping as is in RHS, right? So again mass from the relation density. So this mass we can replace with the density in terms of volume, right? So P2 minus P1 into A, that is equals to density into volume into acceleration due to gravity, right? Why? Because density is equals to mass by volume. Right? Again, the volume of the cylindrical column, right? So volume, that is equals to delta H into A. Volume of the cylindrical column, length into area. So that gives what? The volume of the cylindrical column, right? So P2 minus P1 into A, that is equals to density rho as is. So in place of volume, delta H into A into G, right? So in the LHS we having area and also in the RHS we having area. So those two get cancelled. So P2 minus P1. So change in pressure. So that we can write delta P. So delta P is the change in pressure, that is equals to rho G delta H, right? So now shift delta H to the LHS, delta P divided by delta H, that is equals to rho G, right? So when delta H tends to 0, right? So that is continuity, right? So when delta H tends to 0, that means we are applying the limit, right? So limit delta H tends to 0, that means this surface, that is the depth H is equals to 0, then the top surface of the cylindrical column is equals to the surface of the liquid. So now previous in now derived ಮಾಡಿರುವ pressure, so ಆ ತರ diagram ಬರುತ್ತೆ. So surface of the cylindrical column is equals to the surface of the liquid, right? So limit delta H tends to 0, delta P divided by delta H, that is equals to dP by dH. So limit apply ಮಾಡ್ತಿದ್ದಂಗೆ delta ಇರೋದು ಏನಾಗುತ್ತೆ ನಮಗೆ differential of pressure with respect to differential of depth ಆಗುತ್ತೆ, right? So now this relation becomes dP by dH, that is equals to rho G, right? So dP is equals to rho into G into dH. So calling this as the first relation, right? Change in pressure, that is equals to rho, that is density of the liquid, G acceleration due to gravity, and dH is the change in height, right? So calling that one as the first relation, right? So when H is equals to 0, right? So this depth H is equals to 0 means this surface is equals to the surface of the liquid, then P1 is equals to PA, right? So force which is acting onto the surface A, top surface of A, F1 acting at A. So here we having the pressure P1. So at this point we having the pressure P2, right? So at first point ಅಲ್ಲಿ pressure ಏನಿರುತ್ತೆ P1 ಇರುತ್ತೆ, at second point ಅಲ್ಲಿ pressure ಏನಿರುತ್ತೆ ನಮಗೆ P2 ಇರುತ್ತೆ, because force which is acting perpendicular to the area, perpendicular to area ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ pressure, right? So when this H is equals to 0, that means this surface is equals to the surface of the liquid, then P1 is equals to PA, that means atmospheric pressure, right? So pressure ಏನಾಗುತ್ತೆ ನಮಗೆ atmospheric pressure ಆಗುತ್ತೆ, right? So when H is equals to H, right? So that means it is at a depth H. So ಈ depth ಅಲ್ಲಿ H ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ P2 becomes P. So pressure at a point at a depth H ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಆ P2 ಏನಾಗುತ್ತೆ ನಮಗೆ P ಆಗುತ್ತೆ. So ಅದನ್ನ ನಾವು ರೆಫರೆನ್ಸ್ ಹಾಕೊಂಡಿದೀವಿ, P1 P2 ಅಂತನಾದ್ರೂ ಬರ್ಕೋಬಹುದು, or in other words ಅಲ್ಲಿ so we taken P1 is equals to PA when H is equals to 0. Otherwise we can keep P2 as is. So P2 ಮತ್ತೆ PA so ಸ್ವಲ್ಪ differ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು in general we taken that one as P, right? So now to find the pressure, right, that is starts from PA to P. So limit from PA to P into dP, that is equals to integration of, so limit PA in the P ವರ್ಗು ಇದೆ ಅಂದ್ರೆ height ಎಲ್ಲಿಂದ ಇರಬೇಕು from 0 to h. So that is from 0 to h. So rho g dh, right? So integration of dP, we get P. So applying the limits PA to P, that is equals to, so rho constant, ಯಾವುದಾದರೂ ಒಂದು ಲಿಕ್ವಿಡ್ ಇದೆ ಅಂದ್ರೆ ಆ ಲಿಕ್ವಿಡ್ ಗೆ ಡೆನ್ಸಿಟಿ ಏನಿರುತ್ತೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ಆಕ್ಸಲರೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ಎರಡನ್ನೂ ಇಂಟಿಗ್ರಲ್ ಇಂದ ಹೊರಗಡೆ ತಗೊಂಡು integration of dh ಮಾಡಿದ್ರೆ we get h. So if you apply the limit for h, so that is from 0 to h. Now substituting upper limit minus lower limit, so p minus pa, that is equals to rho g into h minus 0. So first we need to substitute upper limit minus lower limit, right? So here also in place of p, first we need to substitute p minus lower limit, that is PA. So PA is nothing but the atmospheric pressure, right? So from this P is equals to PA plus rho g h, right? So this gives what? The pressure at any point will remains the same. So this difference in pressure, right? So P minus PA. So this is the difference in pressure. So this difference in pressure we call as the gauge pressure, right? So gauge pressure ಗೆ ನಮಗೆ ರಿಲೇಷನ್ ಕೇಳಿದ್ರು ಅಂದ್ರೆ that is the difference in pressure. So it is a pressure with respect to that of the atmospheric pressure. So PA ಅಂದ್ರೆ ಏನು? Atmospheric pressure. So that is what the definition of the gauge pressure, right? So gauge pressure ಅಂದ್ರೆ it is a pressure, right? So it is a pressure with respect to the, that means with respect means relative to that of the atmospheric pressure, or it is the difference in pressure between 2 points in a vertically liquid. So vertically ನಾವು ಯಾವುದಾದರೂ ಒಂದು 2 ಪಾಯಿಂಟ್ಸ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಸೊ ಆ 2 ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಏನು ನಮಗೆ ಪ್ರೆಷರ್ ಡಿಫರೆನ್ಸ್ ಇರುತ್ತೋ, ಸೊ ಆ ಪ್ರೆಷರ್ ಡಿಫರೆನ್ಸ್ ನ ನಾವೇನಂತ ಕರೀತೀವಿ? ಗೇಜ್ ಪ್ರೆಷರ್ ಅಂತ ಕರೀತೀವಿ, ರೈಟ್? ಸೊ ಇನ್ ಜನರಲ್ ಆಗಿ ಹೇಳೋದಾದ್ರೆ ಇಟ್ ಈಸ್ ಎ ಪ್ರೆಷರ್ ವಿಚ್ ಇಸ್ ರಿಲೇಟಿವ್ ಟು atmospheric pressure. So we define the pressure at a point relative to atmospheric pressure, so that we call as the gauge pressure, right? So P is equals to PA plus rho g h. So h is at a depth, right? So this indicates, so this relation gives the pressure is same at all points at the same depth irrespective of the liquid which is contained in the container. So ಯಾವುದಾದರೂ different shape ಅಲ್ಲಿ containers ಅಲ್ಲಿ liquid place ಮಾಡಿದ್ರೆ, so at the same point, so ಒಂದೇ same depth ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ pressure ಏನಿರುತ್ತೆ? Same ಇರುತ್ತೆ. So that gives what the relation P is equals to PA plus rho gh, right? So that is, it gives, so the relation gives pressure at a point pressure at all point, right? So pressure at all point at the same depth, at the same depth in the liquid remains same irrespective of the shape of the container, right? So ಇದರಲ್ಲಿ ಎರಡು ಬರುತ್ತೆ, ಒಂದು gauge pressure, so the second one, so this statement is called as the hydrostatic paradox, right? So hydrostatic paradox anta andre ಏನು ಅಂದ್ರೆ, so pressure at all points at the same depth, so pressure at all points at the same depth in the liquid is remains same irrespective of the shape of the container. So different shape of the container alli same depth alli namage pressure ಎಷ್ಟಿರುತ್ತೆ ಎಲ್ಲಾ ಕಡೆನೂ pressure ಏನಿರುತ್ತೆ ನಮಗೆ remains same ಇರುತ್ತೆ, right? So that is given by the hydrostatic paradox. So ಆ statement ಗೆ ನೇಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ hydrostatic paradox. So ಇದಕ್ಕೆ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಅಂದ್ರೆ so consider three vessels, right? So A, B, and C, right? So consider three vessels of different shapes, right? So in three vessels are connected to one horizontal pipe, right? So horizontal pipe ಗೆ three vessels nu connect ಮಾಡುತ್ತೆ. So this one is the horizontal pipe, right? So consider three vessels of different shapes. So three vessels A, B and C, right? So these three vessels is connected to the horizontal pipe, and now the water or any liquid which is filled into these containers. So ಯಾವ್ದಾದ್ರು ಒಂದು liquid ನ ಈ ಮೂರು containers ಗೆ fill ಮಾಡಿದ್ರೆ so in all the containers from the top level only, so each vessel consists of different volumes. So volume of the liquid or water different irutte, but top surface alli level of the water enirutte namage in all the three containers remains same irutte. So if you observe here, so level in A, so E level alli namage B alli kuda water ಇದೆ, so ಜೊತೆಗೆ C alli kuda water ಇದೆ. So that is the best example for the hydrostatic paradox, right? So hydrostatic paradox ke best example, that is because pressure at the bottom of the liquid column at each container, so each container alli kuda E level alli pressure ಏನಿರುತ್ತೆ same ಇರುತ್ತೆ, right? Pressure at the bottom of each container remains same, right? So bottom level alli ella kadegunu pressure same irodrinda, so namge water level in all the three containers kuda ಏನಿರುತ್ತೆ remains same irutte. So ಇದು straight line ಇಲ್ಲ ಅಂದ್ರೆ ಇದನ್ನ straight ಆಗಿ draw ಮಾಡ್ಕೊಳ್ಳಿ, right? So this is the best example for the hydrostatic paradox, right? So here we discussed about the gauge pressure, then hydrostatic paradox. So idu derivation ಕೇಳೋ ಚಾನ್ಸಸ್ ಇಲ್ಲ, but you need to understand the concept. So how we get the relation? So pressure at any point. So ನಾವು ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ pressure at any point in a liquid ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಂತಿದೀವಿ ಅಂದ್ರೆ ಅದ್ರ ಜೊತೆಗೆ atmospheric pressure plus rho g h, so that in the liquid or in the fluid, right? So this is about the gauge pressure, right? So gauge pressure ಗೆ one more definition ಅಂದ್ರೆ it is the difference in 2 points. So it is the difference in 2 points separated vertically in a fluid by a certain distance, right? So so idu general ಆಗಿ ಹೇಳ್ಬೋದು ನಾವು relative to, or in other words difference in pressure. So difference in pressure ಯಾವ್ದ್ರಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ vertically difference in pressure ಇದ್ರೆ ಮಾತ್ರ ಅದನ್ನ ನಾವು gauge pressure ಅಂತ ಕರಿತೀವಿ. In case ಅದು horizontal ಆಗಿ, for example I will consider one point A here. So at the same length along horizontal, if I consider at point B, so point A ಅಲ್ಲಿ pressure ಏನಿರುತ್ತೋ at the same point B ಅಲ್ಲಿ ಕೂಡ pressure same ಇರುತ್ತೆ. So that means pressure at A minus pressure at B, that is difference in pressure ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. So hence gauge pressure is always defined as it is the 2 points separated. So ಎರಡು ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂತೀವಿ, ಎರಡು ಸಪರೇಟ್ ಆಗಿದೆ. So ಯಾವ ತರ ಸಪರೇಟ್ ಆಗಿರಬೇಕು ಅಂದ್ರೆ separated vertically, not horizontally. Right, so vertically separated by a small distance. So small distance ಅಲ್ಲಿ ನಮಗೆ ಎರಡು ಪಾಯಿಂಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so there we are getting the gauge pressure. So at point A we having the pressure PA, at point B we having pressure B. So then gauge pressure is equals to PB minus PA. Right, so that difference in pressure between the 2 points in vertical. So vertical ಅಲ್ಲಿ ಎರಡು pressure difference ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, gauge pressure. So if in this case along horizontal ಇತ್ತು ಅಂದ್ರೆ pressure B, pressure at point B is equals to pressure at point A. So hence the difference ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. Right, so ಅಲ್ಲಿಗೆ ನಮಗೆ ಹೇಳ್ತಿರೋ ಡೆಫಿನೇಷನ್ ಏನಾಗುತ್ತೆ, ರಾಂಗ್ ಆಗುತ್ತೆ. So hence we need to mention this particular word separated vertically. So word ಬಿಟ್ರಿ ಅಂದ್ರೆ so gauge pressure ಗೆ meaningless ಇರುತ್ತೆ. So better you need to remember this one. So gauge pressure is the pressure relative to the atmospheric pressure. So atmospheric pressure means at a surface. So ಇಲ್ಲಿ pressure ಏನಿರುತ್ತೋ so ಅದನ್ನ ನಾವು atmospheric pressure. So previous derivation ಅಲ್ಲಿ consider ಮಾಡಿದಂಗೆ one surface is on the surface of the liquid. So surface of the liquid ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿರೋದ್ರಿಂದ so pressure at a depth. So from the surface ಇಂದ ತಗೊಂಡ್ರೆ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನು ಪ್ರೆಷರ್ ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, atmospheric pressure PA. Right, so that is PA. Right, so always starts with the weight. So ಅದನ್ನ ನಾವು ಕಂಟೈನರ್ ಯಾವ ಶೇಪ್ ಅಲ್ಲಿ ಬೇಕಿದ್ರು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ಈವನ್ ಈ ಶೇಪ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು we are getting the same derivation. Right, so ಇದು ನಾವು 2 times practice ಮಾಡಿ ಸ್ವಲ್ಪ ಲೆಂತ್ ಇದೆ, but starts with the 3 points. So first consider one container. So in that container consists or consider one cylindrical column of length delta H. So consider ಮಾಡಬೇಕಾದ್ರೆ we consider the small gap. So small distance separate ಇರುತ್ತೆ, so ಅದನ್ನ delta H ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Then the liquid is at rest, so hence the forces acting on the cylindrical column is in equilibrium. So there are the forces which are acting on the cylindrical column. One is the force F1 which is acting vertically downward, and the another one is the force which is acting vertically upward, and the third one is the weight of the liquid which is present in the cylindrical column which is acting vertically downward. Now the forces are on in equilibrium, so F1 plus weight, that is mg, minus F2, so that is equals to 0. So now substitute in terms of pressure, and if we derive, so we get the relation P is equals to PA plus rho g H. Right, so next class we discussed about atmospheric pressure and the instruments which we are going to use the atmospheric pressure. Right, so that is barometer. Right, barometer and manometer. So that we will discuss in our next class. Right, thank you.